In this lesson, we will focus on how to solve one-step equations that include multiplying and dividing. We already solved equations on how to add and subtract. Now we are moving to multiplying and dividing. Remember, start with your train tracks to separate the different sides of the equations. You want to make sure that you have one side compared to the other. When you are completing the problem, you are going to do the opposite operation. The technical vocabulary word for that is the inverse operations. And the whole reason we separate them with the train tracks is to note that whatever we do to one side, we need to do to the other side to keep the equation balanced. Then you solve it and go back and check your answer. This is one of the easiest tests to get a perfect score on if you take the time and go back and check your answers. Remember, throughout the video, pause and write anything down that you may be missing. Our first example is, I'll leave the essential question up there for you. Our first example is -8 times x equals 56. So, step 1 says to take the train tracks and separate out the problem. So I'm going to take out my train tracks to separate the problem, which means I am comparing the -8x to the 56. I know that when two numbers are right next to each other, it means that they are multiplying. So the inverse operation, the opposite operation, is to divide. So I'm going to divide. What am I going to divide by? The exact same thing that is bothering my variable. In this case, the exact same thing that's bothering my variable is that -8, so I'm going to divide by -8. Whatever I do to one side, I need to do to the other, so I'm going to divide this side also by -8. I know over here that when I take a -8 and divide it by a -8, a negative divided by a negative is a positive. Whoops, my drawing didn't work out so well. And that 8 divided by 8 is 1. So this turns into a gigantic 1, which leaves me with 1x on this side. Then on the opposite side, I notice that I have 56 divided by -8. I remember my rules that a positive and a negative, when they're dividing, equals a negative. So my answer will be -56 divided by 8 is 7. So I know that 1x equals -7. However, I want to verify my work. So what I'm going to do is go back and I'm going to complete my check. In order to complete my check, this is like a solving and evaluating an expression where I know that x equals -7. And I know that I have the equation -8x equals 56. I'm going to take that -7 for x and plug it in. And then I'm going to solve. Does -7 times -8 equal 56? Yes, it does. -8 times -7 equals 56. 56 equals 56. So this checks out and I got the right answer. If you want to try to do this on your own, feel free to pause and then come back and watch the example. First step I'm going to take is draw my railroad tracks to separate out the problems. Then I'm going to say, well, what am I solving for? I know I'm solving for this x. I know that it's being multiplied by a 7. So the inverse operation is to divide by a 7. I'm dividing by that exact same thing that was bothering it. Whatever I do to one side, I need to do to the other. So I'm going to divide this side by 7 as well. Remember that when I take 7 divided by 7, it turns into my gigantic 1. That one looks better. So on this side, it just leaves me with 1x. On the other side, I need to take 49 and divide it by 7. 49 divided by 7 is 7. So I know that 1x equals 7. Then just to verify, I'm going to go back and check my work. When I check my work, I write down the original problem, which said 49 equals 7x. I know that x equals 7 because that's what I solved it to be. I'm going to plug it in. So this is 49 equals 7 times x, but I solved x to be 7, so I'm going to do that. Now I have 49 equals 7 times 7, which is 49, and is that true? Yes, it is. So that checks out, and I know I got the correct answer. Go ahead, pause the video, take about 10 minutes to solve those two problems, and then come back and see how you did. All right, so hopefully the first step that you took was to set up your railroad tracks, and then look through and say, all right, what do I have going on here? I know that I have 21 times r, because when they're right next to each other, they're multiplying. The inverse or opposite operation then is to divide, and I'm going to divide by the exact same thing, bothering that r. So I divided both sides by 21. I then know that this turned into my gigantic 1. So I have 1r equals, I know a positive divided by a negative is a negative, and I know that 21 goes into 63 3 times. I'm then going to come over here and complete my check just to make sure. When I complete my check, I go back to my original equation, which was 21r equals negative 63. I know that my r equals negative 3, so I'm going to take 21 times negative 3 equals negative 63. Then I'm going to multiply. I know that 21, a positive 21 and a negative 3 is going to equal negative. And when I figure that out, I get 63. And did I want negative 63? Yes, I did. So that checks out, and I know I got the right answer. So again, my answer would be 1r equals negative 3. Looking down at the bottom then. Sorry, just want to hide that from you really quick. Looking at this problem, we have negative 12m equals 144. So again, I'm going to do the same thing. I know that these were multiplying, so I know I have to divide. I divide both sides by a negative 12, because negative 12 is what is bothering the m. This turns into my gigantic 1. I can't do it when I come from that side. There we go. So I have 1m equals a positive divided by a negative is a negative. 144 divided by negative 12 is negative 12. I'm going to complete my check, which means I take my original equation, which was negative 12m equals 144. I'm going to plug in the negative 12 that I got for my answer. So now I have negative 12. M was negative 12, and that equals 144. I know that a negative times a negative is a positive. That 12 times 12 is 144. And does that equal 144? It sure does. All right, here's another example for you. Go ahead, try that one, and then pause and then come back. When you are solving this problem, again, set up your railroad tracks first. It's very important that you take the time to show your work, because these are only going to become more complex as we move into two-step equations and multi-step equations. I know that the 9 and the p are multiplying, so I need to divide because that's the inverse operation. Whatever I do to one side, I need to do to the other. Negative 9 divided by a negative 9 is a positive 1. So it just leaves me with 1p. Negative divided by a negative is a positive. 72 divided by 9 is 8. So I know that my answer is positive 8. If I went over here to check my answer, I know that my original equation was negative 9p equals negative 72. I said that p equals 8, so I'm going to substitute in the 8 for that. Negative times a positive is a negative. 9 times 8 is 72. And does negative 72 equal negative 72? It sure does, so I know it checks out. What happens if it looks like this? Well, then we ask ourselves the same questions just as we did before. Always starting with our railroad tracks. Know that I need to solve for D. In order to solve for D, I need to say, well, what's bothering it? Well, this 6 is. How is the 6 bothering it? Well, this fraction bar. And remember that fraction bar means to divide. What is the opposite of dividing? Multiplying. So I'm going to multiply both sides by 6. Whatever I do to one side, I need to do to the other side. So these 6's cancel out, and it leaves me just with the letter D. 12 times 6 is 72. I can do the same thing here that I did in the last example and go back and check my work. When I go back to check my work, I start with the original expression, or equation, excuse me, and plug in the value that I found. I found D to be 72, so I'm going to plug 72 in. Then I'm going to divide it by 6 and see if I get 12. As I do that, 72 divided by 6 is 12. 12 equals 12, so it checks out. Excuse me. What happens if there are negatives involved? Ooh, and this one's a little bit even more tricky. It has the variable on the other side. I'm still going to take the same steps. Step 1, draw my railroad tracks. Step 2, ask myself, what's bothering that D? Well, the negative 9 is. So I have to ask myself how? By dividing. What's the inverse? To multiply. So I'm going to multiply both sides by negative 9. Whatever I do to one side, I need to do to the other. I know a negative times a negative is a positive, and 2 times 9 is 18. I know that over here, these are going to cancel each other out and leave me just with the variable D. So my answer is positive 18 equals D. Again, I'm going to complete my check just to make sure, because it's an easy way to get an A on the test. I bring back my original equation of negative 2 equals D over negative 9. I know that my D was a positive 18, so I'm going to put positive 18 on the top and then fill in the rest of the equation and then solve it. Does 18 divided by negative 9 equal negative 2? Yes, it does. So I know that I checked it out. I know that my answer works. Same idea. What I want you to do is hit pause and try solving these two equations and then come back for the answer. All right, again, I'm going to set up my railroad tracks. I recognize that the D is being divided by a positive 2. So the inverse is to multiply by a positive 2. So I'm going to multiply by a positive 2. The 2's over here are going to cancel out. And over here I'm left with 36 times 2, which is a negative 72. Positive times a negative is a negative. As I complete my check, I know that the original equation was D over 2 equals negative 36. I just found that D was negative 72. That needs to be divided by 2. Negative 72 divided by 2 does give me an answer of negative 36, and that checks out because that is the answer that I wanted. D minus 9, D divided by a negative 9 equals negative 4. Same thing here, step after step. What's bothering the D? A negative 9. How is the negative 9 bothering it? By dividing, so the opposite is to multiply. So I'm going to multiply both sides by a negative 9. Negative 9's cancel, leaving me with D. Negative times a negative is a positive. 4 times 9 is 36. My answer for this is 36. I go back and check my work, which you should have done already. And in checking my work, I plugged in 36 for the D, which needs to be divided by a -9. And I hope that it equals -4. And in doing so, that's the answer that I get. I find that -4 equals -4. I would like you one more time to go ahead and hit pause. Well, let me get this question there. And solve that question. Hopefully, when you were solving this question, you drew your railroad tracks. You knew to multiply both sides by -3 because that is what was bothering, and the inverse operation from division is multiplying. These cancel out, leaving me with the letter D. 5 times -3 is -15. And you would have known that because you would have already gone back and verified by checking your work. Summary. What do I need to know? I need to know the steps to solve a one-step equation I must use inverse operations to solve a one-step equation. I must use inverse operations. Make sure you check your work as you go along. And here is your homework. Your homework is page 72, 8 through 21, 36, and 37.